Welcome to the third and final video in the series on assessment. We will be covering summative assessment. The objectives are twofold. Given a learning objective, you will be able to match a summative assessment that is congruent with the student objective. And you will be able to identify at least 4 summative assessments in which not all are traditional assessments. And we'll be talking later in this PowerPoint about what are considered traditional assessments. I want to start with a reminder that whatever is identified by your lesson's learning objectives, it must be linked to a summative assessment. And so the next 3 slides are going to give you some practice of what is meant by this. Matching or congruency is critical. So let's check yourself in terms of looking at a learning objective. This is taken from the K2 Engineering NGSS standards. Develop a simple sketch, drawing, or physical model to illustrate how the shape of an object helps it function as needed to solve a given problem. So what would be a summative assessment? Well, it would have to be an illustration through drawing or building a physical model, because that is what it's saying. Develop a sketch or a physical model. So that's what you have to do. A rubric then needs to check on the accuracy of the sketch or the physical model that is showing how shape solves a given problem. Let's look at another example. This is at the middle school level. Construct an explanation that predicts patterns of interactions among organisms across multiple ecosystems. So a summative assessment could be a written piece in which the student is demonstrating this knowledge, or perhaps it could be a poster or presentation in which that explanation is placed on the poster or in the presentation. Then you would develop a rubric. The rubric must show that you are checking that the explanation accurately predicts patterns of interactions among organisms across multiple ecosystems. It seems so simple, but it can be tricky. Let's look at this one that I pulled from the main standards. Describe the different kinds of objects in the solar system, including planets, sun, moons, asteroids, and comets. So I'm going to give you an assessment, and you need to think, are these an appropriate summative assessment? Because this is what I sometimes have seen in lesson plans. So what about if students read a chapter in the text, in their textbook, that identifies all the objects in the solar system? Would this meet this learning objective? The answer is no, it does not. When the students are reading the chapter, that's only input. The children are not demonstrating anything. In a summative assessment, they need to show that they have met the objective. Let's try another possible assessment technique. You have a class discussion after you have assigned readings that go over this content, in which you ask the class to name the objects in the solar system, and you write these down on the board as you call on individual students. Would this meet this learning objective? Now the answer is, I hope you've thought about it. The answer is, again, no. First of all, they're just listing the solar systems. They're not describing, but even if they did describe, if individual students described, you cannot say that each and every student has met this objective. Only a few students gave the answers as you wrote them on the board. A summative assessment must be conducted that cover all of the students. So what could you do? Well, a short answer exam question or a science notebook in which the student needs to describe the different kinds of objects in the solar system would be appropriate. Or a poster or a model could be built as well, as long as there are descriptors with each object, because it's talking about describing the different kinds of objects. Okay? So I hope this makes it clear, because it does seem so simple, but I think it's one of the hardest things to get teachers to really match their learning objectives with a summative assessment. So let's move on, though, and look at 14 possibilities of summative assessments. We're going to start with some traditional ones, and then we'll move to some more authentic ones. So traditional ways, we're going to sort of go over the pros and cons of each of these. End of the chapter homework. If you have a textbook in science, many times at the end of the chapter, there will be some questions. The pro or the positive thing tells students you are serious about the content, helps parents know what is being taught in science. The con is that it doesn't tell you much about what children know. These questions generally are at a very basic recall level. It does not tell if they like science, and we should be concerned about that too. Many times these exercises will not pique the children's interest to learn more of the content at all. It will just be seen as a boring exercise. Quizzes. The positive tells whether students can think fast and have sufficient command of writing, easy to grade, and provide a snapshot of a student's recall of information. Keep students on their toes. And actually, I have to tell you, the research in education shows that if there's information that the students must memorize, quizzes are the best way to have them rehearse the information and learn that information. But the con is that it doesn't tell about in-depth understanding. Poor scores may not reveal deficit in knowledge, but deficit in being able to express themselves quickly. Or you may pick things to go on the quiz that may not totally cover what they may know in the area. Tests are a little bit are larger than quizzes generally. The pro, again, provides a way to assess student progress and a way to compare one student with others. Neat and tidy way to get information for grading purposes. However, if items are mainly on the basic recall level, then that's all you're assessing. You're not assessing critical thinking or whether they can, plan an experiment or any of those things. So think about if you can, because there are ways that you can develop items that could assess more application. And so think about pushing that to do those items. Library reports. The pro can round out the student's knowledge of an area, can improve a child's grade if you're using it for extra credit. But on the con, a library report generally tells you whether children can look up information in reference books and summarize what they have learned. Hence, the report does little to extend and enrich the basic knowledge, skills, and attitudes emphasized in what the NGS is now looking at in terms of hands-on, minds-on science. Standardized tests. The pro is it provides an opportunity to compare how your students are doing compared to children across the country. The con is that these tests many times do not emphasize concepts learned through hands-on experimentation, as we've mentioned above, such as science process skills and attitudes. So let's look at some more what we would call authentic assessment, and one is a short task, prompt, and rubric. A prompt is a question or a group of questions that provide a task, directions, and the students conduct the task, completing a science lab write-up. So here's an example. It's really looking at sound. It gives the directions to the students. I'm not going to read the whole example. And then there's a quick, simple rubric in terms of 210 as far as what you're looking at with your learning objectives. So you could develop short tasks with prompts and have a very simple rubric to go along with it. A full lab assessment is generally more involved than a prompt and tends to be more inquiry-based, or that the students would set up the experiment. Here's an example, and I actually used an example about plants. Students are given a challenge of having 1 week to find out what will happen to the plants if they're kept in a closet without light. Actually, your Fast Plants lab is truly an example of a full lab assessment where you are setting up the investigation, coming up with a question, controlling the variable, etc. So, and generally, it's a science notebook or a science lab that is that accompanies a full lab assessment. Oh, and this is a sample rubric that would be used to look at a full lab. And notice that you will see what you're looking for: criteria, the prediction, the test, testing the prediction, daily observations. So I am assuming the learning objectives are talking about that the students are able to generate a testable prediction or hypothesis. that they are able to control variables, that they are able to make observations that are accurate. So this rubric would go along with what your learning objectives would be asking for a lab setting. Additional summative assessment tools. I've already mentioned this in conjunction with the lab, but science journals or notebooks are chronological collections of student recordings. I label a science notebook or journal something that the students will utilize during an inquiry lesson or a unit such as the FAST plans. Do know that in the formative assessments, we also talked about journals in the way of looking at attitude towards science. But when I put science journals together, it tends to be more of a lab notebook. Portfolios is an organized collection of a student's work that shows the very best that he or she can do. So a student, over the course of maybe a term, will be able to pick different parts of a lab that will show that they can graph data correctly. So they will pull that portfolio together to show that they have met certain objectives. Many times portfolios are used in competency-based education. Anecdotal records are teachers' brief observation notes, for example, about a child's ability to utilize certain science processes. And we're going to actually show you at the end of this PowerPoint a couple of observation techniques that you can use. Concept maps. We talked about these in formative assessments, but you could also use concept maps to grade or use as a summative assessment in terms of looking at what their knowledge was like at the beginning, and then at the end, how they are seeing this concept and looking for a lot of connections. And in terms of looking at how, I think it was an example of the monarch butterflies, what is interacting in that ecosystem. Science conferences with children is basically sitting down. It is time intensive, but actually interviewing them to see what they know about a topic, that may be appropriate, especially with younger children. But again, you have to do it with all children. So it probably would be a few that you would do at a time. Children's self-assessment could be worked into the summative assessment and grade. In your FAST Plans science lab, you're going to see that at the very end, there's a yellow page that you will be self-assessing yourself, and then a blue page that I will be assessing you. And you could be looking at how accurately do children self-assess themselves. Remember, again, that with all of these, you'll probably be developing a rubric by which you would grade the student, and that the rubric must clearly assess what your learning objectives indicate. I want to throw out the fact of considering affective development checklists. I'm not going to read all of these. Again, there'll be a PDF of the PowerPoint up in our Blackboard course site. But think about that you might want to have some learning objectives that deal with whether they seek out science, whether they ask questions, whether they are curious in many ways. So, are responsible in working in a lab situation. So think about developing the affective checklist as well. A few tips. Share rubrics or indicators ahead of time, just like you like the fact of being able to see a rubric before you have to pass an assignment. The same thing with your students. Share it with them. It will help them become focused in terms of their products. It might be helpful for the students to rate their own work. We already talked about that, using the rubric, and explain their reasons. And observations are important, especially in the younger grades, but must be systematic. Using some formal way to capture your observations if they are to be a summative assessment. So in your lessons, if you're going to use observations, you've got to show what your system will be. And here are a couple of possibilities. This is actually pulled from math. You can see that it says making whole given fraction part, but you could put what you're looking at in terms of the science trait or process. And you just have 3 categories: above and beyond, on target, not there yet. And what you do during the class is you just put the names right there of the students who are showing above and beyond, on target, or not there yet. Very quick, very easy to implement. Another one is to have just a clipboard with index cards with students' names on it, and it's taped over here, so they flip up. And what you can do is you could be looking at what's cooperative and planning and executing investigations. So you're going around to the different teams or groups and you're checking that off, and you could write little anecdotal notes on those index cards. So this is the end of video 3, and it's time for you to quiz yourself. Take one of your learning objectives and match it to a summative assessment that is congruent with that objective. What I would love to have you do is to send me one of your lesson objectives that you've generated, and we will work on it in Monday's class, and that's a way that you can check to see if you're on target. Please email your lesson objective by Sunday night if you want us to do one of yours at the latest, so I can set that up for class. The second thing is that you will be able to check to see if you're able to identify at least 4 summative assessments in which not all are traditional assessments, as I want to push you beyond those traditional ones. So again, this is the end of video 3, and take care.